Hi everyone. Following are two examples regarding discrete random variables. I will be looking at using the properties of a discrete random variable to determine whether a function is indeed a PMF. Then I will also solve some probability problems. I will plot the PMF and the CDF. I will demonstrate the distributive property of expectation, and I will also calculate expectations and variances for the distributions. Now before we start, just a reminder, the definition of a random variable, it is simply a function that maps outcomes from our original sample space, which can be non-numerical, to the number line. In other words, taking values that are possibly non-numerical and assigning numbers to them so that we can do some calculations. Random variable also refers to a population, and in this case we're looking at discrete random variables, which means that we are able to count the number of possible outcomes. Whether they are infinite or finite, it doesn't matter, we are able to count them. Right, first example. We have this probability that is equal to c times x, where x can be 1, 2, 3, or 4. Now c is an unknown constant. The first question is, what value of c will make the function a PMF? Okay, as I said, c is an unknown constant, so we need to figure out what c must be so that this probability is indeed a PMF. So we need to know the definition of a PMF, or properties of the PMF. Secondly, probability of x being greater than 2, okay, strictly greater than 2. Thirdly, probability of x being greater than 1 but less than or equal to 3. And then lastly, we need to calculate the expected value of x, the variance, and the standard deviation of x. Let's just spread this out a bit for some calculation space. Okay, first of all, what value of c will make the function a PMF? Now the property of a PMF that we need to use here is the one that says if we take all the probabilities and we add them together, that's what this sign here means, if we sum together all the probabilities for all possible values of x, then the total must be equal to 1. So that's exactly what we'll do. We'll take 1 and we'll say that that must be equal to the sum of c times x for all possible x values. Now, if we look at the expanded notation, then it's simply going to be c times 1, because 1 is the first x value. Okay, c times 1, plus c times 2, because 2 is the next x value, plus c times 3, plus c times 4. And adding those up must be equal to 1. So we have 1c plus 2c plus 3c's plus 4c's. Adding this up, we get 10c. So that means that 1 is equal to 10 times c, and that means that c is equal to 1 over 10. So this c over here, my probability function, must be equal to 1 over 10. So that means that my PMF is actually x over 10. Okay, you can see I just wrote it over here, x over 10. It was c times x, but c is equal to 1 over 10, so this is just equal to x over 10. Now, next one is the probability of x greater than 2. Now, personally, I prefer to write greater than or equal to. It is my personal preference. You do not have to do that. However, if you write this x greater than or equal to 3, then we know that we need to start at 3. We don't have to remember over here it's greater than 2, so that means 3. Here we simply start at 3. So because this is greater than or equal to 3, we need to consider all x values 3 and more. Okay, 3 and greater. There's only two of them. There's 3 itself and there's 4. So we need to add those two probabilities together, where x is equal to 3 and x is equal to 4. And of course we'll use our PMF, so x over 10. So we'll simply substitute 3 into x, and then we'll substitute 4 into x, which will give us 3 over 10 plus 4 over 10, and that gives us 7 over 10, or 0.7. Now the next one, fairly similar. We have the probability of x greater than 1, less than or equal to 3. Again, I prefer to have x greater than or equal to 2, and also less than or equal to 3. So that means x needs to be 2, and we'll plug it into our PMF, and then we'll take x equal to 3, we'll plug it into our PMF, so we'll have the sum of two terms again, 2 over 10 and 3 over 10, and that is just 5 over 10, or 0.5. So the probability of being either 2 or 3, if we make a random selection from this distribution, then that probability will be 0.5. If we look at the probability of randomly selecting a value at least 3, in other words 3 or 4, then that probability will be 70%. Right, now to calculate the expected value, then we go back to the definition of expected value, which is really very simple. All that it says is we'll take each outcome, we'll multiply it by its probability, and we'll add together all those products. So doing exactly that, the first outcome is x equal to 1, that one over there. Its probability will be x over 10, but x is 1, so it's going to be 1 over 10, plus x is equal to 2 times 2 over 10. X is equal to 3 times 3 over 10. X is equal to 4 times 4 over 10. So solving that, we get 30 over 10, in other words, 3. Right, next one is the variance. Now for the variance, we need the mean squared. Now we just calculated the mean. It's this 3 over here. And then we need the expected value of x squared. So in other words, we have an unknown value here that we need to calculate. Okay, because the mean squared will just be 3 squared, but e of x squared is unknown. Now how do we calculate it? Well, how do we calculate an expected value? Expected value will be the thing in brackets, in this case x squared. Okay, we'll take the thing in brackets, we'll multiply it by its probability, and we'll add all those products together. So what do we have? Well, x can be 1, so that means 1 squared times 1 over 10. X can be 2, so that's 2 squared times 2 over 10, all the way to 4 squared times 4 over 10. So, summing that, we get 100 over 10, which is equal to 10, of course, and then we can substitute that into our variance calculation. So that'll be 10 minus 3 squared, that's 10 minus 9, which is just 1. Right, now, next I want to look at the graphs of the PMF and the CDF. Let's start with the PMF. So the first step would be to construct a table. So we'll need the x values, and then we'll need their probabilities. So the x values would just be 1, 2, 3, and 4, okay, which is just the original values given. And their probabilities, we'll simply take 1 into x, so that's 1 over 10, 2 into x, so that's 2 over 10, 3 over 10, and 4 over 10. So that's how our table will look. And the graph of the PMF will simply be a histogram, okay, or the equivalent of a histogram. Okay, histogram is for samples, remember? So this is the equivalent of a histogram. So we'll simply have the probabilities on the vertical axis, we'll have x on the horizontal axis, and we'll have the bars. No gaps. Okay, these bars are against each other. There's no gaps. Each bar has a width of 1, and of course the height of each bar and the surface area of each bar will be their respective probabilities. You can see here the height of this last bar is 0.4. Okay, that's the 4 over 10. It is for x equal to 4. So if we take the height of this bar, which is 0.4, the width of this bar is 1 unit. It is at position 4, but the width is 1 unit. So width of 1 unit times 0.4, that gives us a surface area of 0.4. Right, what about the CDF? Now the CDF, remember, is the cumulative values. So that means we will not have x equal to, but we will have it less than or equal to. In other words, everything up to that x value, all probability up to that point. So when we have x equal to 1, the only probability we have is 1 over 10. When we have x equal to 2, then we have probability 1 over 10 plus 2 over 10, and that gives us 3 over 10. When we have x equal to 3, we have probability 1 over 10, 2 over 10, and 3 over 10. So that added together gives us 6 over 10. And then of course the last one, probability for x less than or equal to 4. That means we are adding everything together, so we should get 10 over 10. And now we just plot that. But keep in mind, this is a step function. It is not a bar graph. Okay, it is a step function. So let's see what this means. When x is equal to 0, you can see there's no 0 there, no 0 there. So because there's no 0, there's no probability. Okay, there's no probability. So when x is 0, we have nothing. Then at position 1, when x is equal to 1, we make a jump up to 1 over 10. You can see here the jump is up to 1 over 10. Then all the way up to position 2, the probability will remain 1 over 10 until we add the 2 over 10. And then at position 2, we have a jump up to 3 over 10. So that's why we have this empty circle here, just to remind us that the jump takes place over here. So when we are at position 2, we have jumped already. When we're at position 3, the probability increased from 3 over 10 to 6 over 10 because we added this 3 over 10 when x turned 3. So at 3 we made a jump. And then finally, when x is equal to 4, we made the final jump to 1, or in other words, 10 over 10. But we can also use our CDF to calculate probabilities. So in other words, working backwards from the CDF to the PMF. If we take that gap between between 1 and 0.6, then that's the size of the final jump. So at 4, we made a jump from 0.6 to 1, which was 0.4, which is this value over here. So calculation-wise, we have the probability of x equal to 4, which is equal to the probability of x less than or equal to 4 minus x less than or equal to 3, and the difference between those two is just 0.4. Okay, remember this value over here, that height there represents less than or equal to 4, and this height over here less than or equal to 3. Next, I want to look at the properties that I mentioned in the previous section, where we add and subtract random variables and then calculate their mean and their variance. So in this case, just a reminder that the mean of x is equal to 3 and the variance of x is equal to 1. This was calculated earlier. Now let's consider another random variable, and we'll call that random variable y, and it has a mean of 2 and a variance of 3. Now what I want to calculate is I want to calculate the mean of x plus y, the variance of x plus y, the mean of x minus y, and the variance of x minus y. Now, an additional piece of information, we are told that x and y are independent. Now, this notation over here, mu subscript x plus y, is simply the mean or the expected value calculated after we've added x and y together. However, we know from our results in the previous section that this is simply equal to the mean of x plus the mean of y. So we know the mean of x and we know the mean of y. That is simply 3 plus 2, which gives us 5. Right, what about the variance? Well, if we calculate the variance for the sum, it'll be equal to the sum of the two variances. Another way of writing it will be that. But this will only be valid, okay, this result over here will only be valid if x and y are independent. And seeing as they are independent in this case, then we can go ahead and do this. So now we're simply just adding the two variances together, 1 plus 3. Okay, there's the one variance of x, there's a variance of y, so 1 plus 3 will give us our 4, which is the variance of the sum. Next is the mean of the difference of x and y, so that is simply equal to the mean of x minus the mean of y. So mean of x, which is equal to 3, we subtract the mean of y, which is 2, and that gives us 1. Then lastly, you'll see that it's in red because it's very important to note. If we take x minus y and we calculate the variance for that, then it will be the variance of x plus the variance of y. Doesn't matter whether this is x minus y or whether it's x plus y, this calculation will always be the sum of the variances, always. So in this case, the sum of the variances will still be 4, like it was in the previous case. Right, this is the end of the first example. Let's have a look at another one. Now it says here, let x be a random variable, and it's the number of days that a patient needs to be in hospital. Okay, so x represents the number of days that a patient must be in hospital. X has a PMF given by this function over here. So the probability of a person being in hospital for 1 day will be 5 minus 1 divided by 10. Probability of a person being in hospital for 2 days will be 5 minus 2 over 10. And the same for 3 days and 4 days. We need to calculate the probability that a patient stays at least 2 days. We need to find the expected number of days that a patient stays in hospital. And then it says, if the patient receives 2,000 Rand a day from an insurance company for the first 2 days in hospital, and 1,000 Rand for each day after the first 2 days, what is the expected payment that they receive while they are in hospital? So let's start with question A. Now before we do that, I've included a table over here just to ease our calculations a bit, because it's always simpler to work from a table if the x values are fairly small, or rather if the range of x values is fairly small. So in this case, as I said before, when x is 1, then the probability will be 5 minus 1, so that's 4 over 10, which is that 4 over 10. If x is 2, probability will be 5 minus 2, which is 3 over 10. If x is 3, 5 minus 3, which is 2 over 10. And when x is 4, it's 5 minus 4, which is 1 over 10. Okay, now, first question says the probability a patient stays at least 2 days. So that means x must be greater than or equal to 2. So the probability x greater than or equal to 2 means that we need to consider x equal to 2. Then we need to add it to x equal to 3. Then we need to add it to x equal to 4. Okay, at least 2 means 2, 3, and 4 must be considered. So we have the probabilities for 2, 3, and 4. It's in our table. So that is simply 3 over 10 plus 2 over 10 plus 1 over 10, which gives us 6 over 10, or 0.6. So the probability of a patient staying at least 2 days in hospital is 0.6. Now the next question is, what is the expected number of days? So expectation, start by writing down the definition. The expected value of x will be each x times its probability, and once we've multiplied all the x's and their probabilities, we will add together all those products. Now we can do this fairly easily in our table. Okay, over here I'm creating a third row. You'll see it's in red, x times its probability, x times its probability. So if we calculate that, then it's 1 times 4 over 10, which is 4 over 10. 2 times 3 over 10 will be 6 over 10. 3 times 2 over 10 will also be 6 over 10. And 4 times 1 over 10 will be 4 over 10. So now that we have x times its probability, okay, we just need to add everything together. So if we take the sum of all these products, you'll see there we're adding them all together, then that total will be our expected value. So it's adding up to 20 over 10, which gives us 2. So the expected number of days a patient stays in hospital will be 2. Okay, the expected number of days a patient stays in hospital will be 2. Now, for the last question, it says here, if the patient will receive 2,000 Rand from an insurance company for the first 2 days and 1,000 Rand for each day after the first 2 days, what's the expected payment for the hospitalization? So what I'm going to do is I'll start off by looking at the original table where we have the 4 days and we have the probability of staying for those different days. So staying 1 day has probability 4 over 10, staying for 2 days probability 3 over 10, 3 days 2 over 10, and 4 days 1 over 10. Now it says here the patient will receive 2,000 Rand for each of the first 2 days. So that means if you're in a hospital for 1 day, you will get 2,000 Rand. If you are in hospital for a second day, then you will get another 2,000 Rand. Then 1,000 Rand for each day after that. So if you're in hospital for a third day, they'll give you 1,000. And if you're in hospital for a fourth day, they will also give you 1,000. But these are not the only amounts that you actually have. After 1 day in hospital, you have 2,000 Rand. But after 2 days in hospital, you don't have 2,000 Rand, you have 2 plus 2,000 Rand. So you have 4,000 Rand. After 3 days in hospital, you will have the 4,000 that you've accumulated in the first 2 days plus this 1,000, so that gives you 5,000. And then at the last day, the fourth day, you will add another 1,000, which will give you 6,000. Right, so the amounts that you will have for day 1 will be 2,000. At the end of day 2, you will have 4,000. At the end of day 3, you will have 5,000. And at the end of day 4, you will have 6,000. Now the question is, what is the expected payment? Well, expected value is nothing but the product. But here we take the rands and the probability. So the probability of getting 5,000 rand is the same as the probability of being in hospital for 3 days, and that is just 2 over 10. So that means that each of these probabilities are associated with those amounts. So we simply take each amount multiplied by its probability and add them up. So 2,000 times 4 over 10 is 8,000 over 10. 4,000 times 3 over 10 is 12,000 over 10. 5,000 times 2 is 10,000 over 10. And 6,000 times 1 is 6,000 over 10. So adding them up, we get 36,000 Rand divided by 10. That's 3,600, which will be the expected amount for our hospital stay. Right, so the calculation is exactly the same as the calculation for part B. Only difference is now we're not using the days, we're using the amounts that take the place of the days, because we're interested in the expected amount and not the expected time like we were in question B. Right, that's the end of example 2.